Hey, folks. Okay. Well, this time I wanted to look a little bit at the OO side of things. So, what does our system have to keep track of as it's going through and trying to compile an object-oriented language? So, the big thing I wanted to focus on first was just the issue of scope. Right? Most object-oriented languages still have the same idea of a lexical scope. You can have a something that's global or something that's local to a function or local to a block within a function. So that kind of lexically scoped idea. But there's also now this idea that we've got fields and methods defined in classes and inherited by other classes. And so when you see a reference to something, it could very well be a reference to one of these inherited fields. So now we've got an additional form of scoping that we've got to try and resolve. So when the compiler's going through and trying to model our OO language, it has to have some kind of a scope resolution mechanism that will handle that. So we'll introduce the idea of object records. So we'll think of the information that's associated with an object just as we had kind of the idea of an activation record for thinking about the information that's associated with a particular function call. So for a class, we might have a bunch of different data fields associated with it, and we've got the methods that are associated with it. But with an actual instance of it, so with some specific object, of course we're going to have the actual data values that have to be recorded with that, and we're going to have the methods that it's going to be able to refer to. So we'll think about an object record as just this collection of information associated with an individual object. Now, we're also going to go through and start introducing tables associated with the classes themselves, but we'll kind of tackle this one piece at a time. So we've got the fields associated with an object, and that's going to include fields that you've inherited from an ancestor. So, if the top level class defined a field X, and the next level class inherited from that and defined a field Y, and then the next level class inherited from that and defined a field Z, then in an object of that bottommost type, you've got fields for X, Y, and Z stored someplace. So all of those have to be in the object record somehow, or accessible through the object record somehow. Now, if you've got a language that supports multiple inheritance, where you can have multiple different parent classes, then you've also got to have a mechanism to sort of record all of the information inherited from each and to resolve any possible name clashes between them. So, if you inherit a print method from one class, one parent, and a print method from another parent, if you just say print and you haven't overridden it yourself, which one do you get? Or does the language prevent you from doing that? Do you explicitly have to say, I want the print from this parent, or I want the print from that parent? So either there needs to be some kind of default resolution mechanism where, whatever order you said you'd inherit from is the order that's used in resolving this, or there's got to be a mechanism for saying, no, you have to tell me which one you're using, and then I'll give you the correct one. So again, this has to be accounted for in some fashion by the compiler when it's going through this process. Now, we've got this idea that maybe there's methods associated with a base class, and then some of those are overridden by a class that inherits from that, and it defines some new ones, and a class that inherits from that defines yet some more, and maybe overrides some of the ones it got from one of its ancestors. So somehow we need to be able to keep track of the method implementations directly associated with each of the individual classes, and some way to follow this kind of inheritance hierarchy. So if I call method foo, I have to be able to figure out which version of foo is the correct one. So we've already seen this idea of having, if I want to keep track of the different scopes that are available, I'll have a linked list of symbol tables, one for each scope, and I might have a linked list of the activation records for the active functions. And now we've got this idea of a table of object records for all of the in-scope objects right now. And we might also be looking at a linked list of tables, or a tree or a graph of the class inheritance hierarchy. And for each class, we'll have a table that gives access to the methods associated with that particular class. And presumably also pointers to, the classes that it inherited from. So we can start following this kind of tree or chain of pointers to go through and find the right table that's got the implementation of the method that we're looking for. And again, this is probably just going to be a kind of a straightforward list if we're only inheriting from one parent. But if we can inherit from multiple parents, then you can have, sort of fan out and fan in, if you like, multiple different classes inheriting from a specific parent, and each class inheriting from possibly multiple different parents. So in terms of actually figuring out the access to a method, the compiler's got to insert code so that the correct method gets called at runtime, right, at the point of call. So it could take a similar approach to the ones that we've looked at in the past, where we say, okay, well, let's, if we've got this kind of linked list, for instance, of tables for our ancestor classes, then maybe we say, well, let's say how many layers up this list we have to go. 0 is my current, 1 is my parent, 2 is their parent, 3 is their parent, etc., etc., etc. And then an offset that tells you, okay, within the table for that parent or for that ancestor, where do I find the method that I'm looking for? So if you've got an offset for the pointers for each of the different methods in that ancestor. So you can use, again, this kind of pair system where you say, okay, tell me which ancestor, how many links up the chain do I have to go, and tell me what's the offset to the right method for that ancestor. So you follow the chain of tables to the right ancestor, use the offset to get to the right pointer for the right method for that particular class. Now, you will hear the terms closed and open class structure. So the idea of closed is that you can figure all this out at compile time. At compile time, you can figure out the right method to call in the right ancestor. The open class is more the sort of dynamic dispatch idea where you've got virtual methods that you're playing with and whatnot, where it's not until runtime that you can figure out which is the right method that I need to invoke right now. In which case, there's got to be some mechanism inserted in the code that the compiler is generating to figure out as it runs which is the right one to execute. So again, one possible approach is a table for each class and a pointer to each method. So the table for the current class would have a pointer for each of the methods that's defined for that class and a pointer to each parent. And then for each object, we would also have a table. One that's one entry for a direct pointer to each of the methods that it uses by default. So when you create this object, you're going to go through and populate it and say, okay, if on this object I call blah, which of those ones does it access? So I can just kind of optimize my access a little bit. If I access something through this object, this is the one I'm going to jump to. And you're going to have the entries for each of the fields in that object, and you're going to have a pointer to the table for the class for that object so that you can get at the methods that are defined there, or you can follow its pointer chains to its parents or its pointer tree to its ancestors and find the right invocation of the right table, or the right method rather. So there are all sorts of different possible approaches to this. What we're going to do in the next couple of sessions is look a little bit at the structure for a kind of C++-ish approach for this. So things to keep in mind, and then soon we'll start getting into the actual code generation.